Hey everyone, today we're going to have super short. We're just going to go over positive and negative feedback loops. Before we do that, I just want to review. I know usually we review in class. So I just want to review some of the stuff we've talked about. So first of all, can you tell me what the greenhouse effect is? What is the greenhouse effect? So the greenhouse effect is when we have all of these greenhouse gases trapping heat in our atmosphere. And remember, it occurs naturally, but gases in our atmosphere that are released by humans are contributing to it more and more. So if we talk about the greenhouse effect, what type of energy comes into the earth from the sun? Anyone remember? Infrared or UV? Which one? So UV comes in, and then when it hits, it's transferred into I, our infrared, which is heat. Okay. What's the most abundant gas in the atmosphere? It's not oxygen. What is it? It is nitrogen. Nitrogen, 78% nitrogen. We've talked about greenhouse warming potential, which compares how much, basically how much one molecule can warm the atmosphere. And what do we compare it to? Anyone remember what molecule we compare it to? So we say this molecule can warm the atmosphere this many times compared to, we compare it to CO2. Okay, so CO2 has a warming potential of 1. If it's got a higher warming potential, it's going to be able to warm the atmosphere further. So what are some of the gases that have a really high warming potential? So CFCs have a really high warming potential. Methane also is higher than CO2. A lot of things are higher than CO2, but methane is about 24. CFCs can get into the hundreds or thousands. So there's a lot of gases that can warm the atmosphere a lot more. The problem, though, is that we oftentimes think of CO2 because CO2 is most abundant. That's the one that's being produced significantly more than all of the other ones. So let's talk about where these gases come from. Carbon dioxide. Where does carbon dioxide come from? Fossil fuels, plants and animals, respiration, right? Decomposition, but mostly fossil fuels. Let's talk about methane. Where does methane come from? So methane can come from cows. It can come from soils that are underwater. It can come from landfills. And as you saw, it can come from permafrost. That's the main one that comes from permafrost. That was the video clip that I linked today. Nitrous oxide, where does that come from? So that comes from fossil fuels. And then it also comes from agricultural processes. So think about it. Fertilizer has nitrogen in it. So when we are producing fertilizer, when that fertilizer is breaking down, it produces nitrous oxide. CFCs, where do those come from? So those come from man-made products. So things like refrigerants and aerosols, water vapor, and then we have ozone. And ozone is naturally occurring in the stratosphere. Anyone who remembers what type of UV rays the ozone blocks? The ozone blocks UVB rays. So we talked about some trends yesterday. And then really the biggest thing that I need you to understand from those trends is the parts that have warmed and cooled the most. So parts of the world that have warmed the most, we said, was up by the North Pole, and parts that have cooled the most is down by the South Pole. So we're going to look today at positive and negative feedback. So yesterday I gave the assignment to do the positive and negative feedback and explain to them, and it gave you different examples. A lot of times they like to give examples and ask you if which is an example of positive feedback or something like that. So when we talk about climate change, the reason climate change is such a big deal is because we have lots of these positive feedback loops in play. So positive feedback loops increase whatever change we have. Negative reverses the change and brings things back to normal. So if you remember back in biology, you probably talked about positive and negative feedback when you talked about homeostasis. Positive feedback, we talked about like giving birth or blood clotting. The example I often give is that with blood clotting, what happens, you get a cut and more platelets come to the site and they release chemicals that attract more platelets, so and then they release more chemicals and more platelets come and more and more and more. It can also be less and less and less, okay? But the thing is the change is getting bigger. It's increasing that change. It's that snowball effect. Negative feedback reverses the change, so we oftentimes use the example of, oh, you go outside on a really hot day, your temperature, your internal temperature increases a little bit, so your body sweats to bring that internal temperature back down. So reversing the change. In climate change, we have a lot of positive feedback loops, and that's a problem because as climate change continues, some of these effects increase and increase and increase and increase. So one of the examples that they often give, let's just make sure I don't have it on the next slide here. Oh, I do. So take a second and go ahead, pause the video, and I want you to write down if each of these is a positive or negative feedback loop. So I'm going to assume you paused the video. Maybe you did, maybe you didn't, but I'm going to go ahead and give you the answers here. So it says high temperatures increase decomposition in the soil, which release CO2 and increase temperature further. So we start off with a high temperature already, and then at the end, the temperature is increasing further. So if it's high and then it's increasing even more, that's a snowball effect, increasing the change. So that would be positive. Increases in carbon dioxide stimulate plant growth, causing more CO2 to be removed from the atmosphere. So in the beginning, what's happening to my CO2? It's increasing. In the end, what's happening? CO2 is being removed. Okay, so it's decreasing. So this would be negative. So not all of these feedback loops are going to be positive when we talk about climate change, but some of the more troubling ones are the ones that are the positive ones. As Arctic regions become warmer and permafrost thaws, decomposition releases methane, causing the Arctic regions to warm further. So in the beginning, what was happening? They became warmer. What was happening at the end? They became even warmer. So this would be positive. As the temperature increases, sea ice melts, causing more solar radiation to be absorbed by the oceans, melting even more sea ice. So in the beginning, what was happening? Sea ice melts. In the end, more sea ice melts. So this is positive. So this is one you'll hear a lot, these two on the bottom. So the planet's becoming warmer, permafrost is melting, releasing methane. Remember, methane's a greenhouse gas, so it's causing the temperature to increase even further. So they're expecting that as these temperatures increase, they're actually going to start increasing at a more and more rapid rate because of these feedback loops. And then down here, the sea ice, so those are like icebergs, that's going to melt. Remember we talked about albedo being reflecting of that light. So ice is a really good reflector because it is really shiny, it's not very dark. So when the sunlight hits it, it reflects back up into space and it's not absorbed by the ocean. When that sea ice is gone, then all the sunlight goes into the ocean, it's absorbed, and then that causes more sea ice to melt. So positive and negative feedback loops, I know we did it in chapter 2, so I knew it would be a review here. So I just wanted to touch on that.